Hello everyone, this is a tutorial on how to do assignment 13, trig sub from chapter 7.3. Today we're going to figure out how to compute the integral of 1 over x squared square root x squared plus 4. So first we're going to substitute 2 tangent theta for x because this square root right here is in the a squared plus x squared form, which indicates we use tangent. And dx is going to be the derivative of 2 tangent theta. That's going to be 2 secant squared theta d theta. So next we plug in the values for x and dx into the integral. So then we get the integral of secant squared theta over 2 tangent squared theta square root 4 tangent squared theta plus 4. So what we can do next is actually another trig sub. So tangent squared theta is actually equivalent or equal to secant squared theta minus 1. And since this is 4 tangent squared theta plus 4, it would equal to 4 secant squared theta minus 4. And once we plug that in to the square root and take that square root, we get the integral of secant squared theta over 2 tangent squared theta times 2 secant theta. So there's actually some cancellation available there. So we can cancel out the secant theta and the secant squared theta. So there's only going to be a secant theta at the top. And 4 tangent squared theta would be at the bottom. So next we can actually pull out the 1/4 and we get integral of secant theta over tangent squared theta. So now that we have 1/4 times the integral of secant theta over tangent squared theta, we can actually use some trig identities to figure this out. So secant theta is actually equal to 1 over cosine theta, and tangent squared theta is actually equal to sine theta squared over cosine squared theta. So once we plug that in, we get 1/4 times the integral of 1 over cosine times cosine squared theta times secant squared theta. So once we multiply that out, we get some cancellation and get 1/4 integral cosine theta over sine squared theta. So next we do a u sub. So u is equal to sine theta and du is equal to cosine theta dx. So once we have the u and du values, we plug it back into the equation and get 1/4 integral 1 over u squared. And once you take that integral by the power rule, you're going to get 1/4 times negative 1 over u. And once you plug back sine theta back into the equation and multiply by 1/4, you're going to get negative 1 over 4 sine theta. So at this point, we're almost done with the problem. We just got to figure out what sine theta is. So if you remember from above, x is equal to 2 times tangent theta. We got to figure out what theta is, and theta is equal to the inverse tangent x over 2. So how do we figure out sine from this? Well, we're going to draw a triangle and figure it out from there. So tangent, if you remember, is opposite times opposite over adjacent. So x is opposite and 2 is adjacent. And to figure out the hypotenuse, use Pythagorean theorem. So a squared plus b squared is equal to c squared. And for the hypotenuse, you get square root of 4 plus x squared. So sine, if you remember, is opposite over hypotenuse. So this is opposite, this is hypotenuse. So sine theta is going to be x over the square root of 4 plus x squared. So once you have sine theta, you're going to plug that in back into the equation. So what you're going to get is negative 1 over 4 times x over the square root of 4 plus x squared. And since we have a fraction at the denominator of a fraction, we're going to take the take the denominator of that fraction and put it up top. So in the end, we get negative square root of 4 plus x squared over 4x plus c, and that is your final answer. So question 2 is a true or false question. It asks the integral 1 over square root of 9 minus t squared can be made easier to evaluate by using substitution t equals 3 tangent theta. And the answer to this is false, because the square root of 9 minus t squared is in square root of a squared minus x squared form, which means that sine is used, not tangent.